next we're going to look at 4 consequences of the chain rule, and I'm going to divide this into 4 separate videos. First consequence of chain rule, we'll be able to take derivatives of inverse functions, and in doing that we'll prove the derivative of inverse sine. The other 5 are similar. Second, we'll look at something called implicit differentiation. Third, something called logarithmic differentiation. And fourth, related rates. And these will be 4 separate videos. Here we're going to look at derivatives of inverse functions, but first, let's just recall the chain rule. What does the chain rule say? Well, we had 2 different notations. Let's recall this notation. Well, let's write it like this. The derivative of a composition of functions f of g of x equals f prime of the inside times the derivative of the inside. And something like that is going to show up in all 4 of these. In the first one, that notation is more convenient. For the second, third, and fourth, we'll probably stick with the fractional notation. But here we're going to look at how we can use this to find derivatives of inverse functions. Maybe I'll say, we find the derivative of f inverse of x. Well, first, what is a notation for a derivative of f inverse of x? Well, I'll just write it here. F inverse derivative. To separate the inverse from the derivative, I'll say f inverse prime, like that, with parentheses, of x. It's a function of x. And how are we going to do that? Is that going to fit over here? I believe it will. Well, our goal is to find this. So we want to find this. Well, remember a definition of f inverse. One definition of f inverse is that f composed with f inverse is always going to evaluate to x. Well, differentiate both sides with respect to x. So diff with respect to x. WRT with respect to. Differentiate with respect to x. What do we get on the left? 1. What do we get on the right? Well, it's a composition, so we'll get a formula like this. Derivative of the outside times derivative of the inside. Derivative of the outside, f prime of f inverse of x. So take the derivative of the outside function, leave the inside alone, then multiply by derivative of the inside. So times the derivative of f inverse of x. So look at that. Our goal was to find this, and there it is, right there. So all we have to do is solve for it. So f inverse prime of x divide by this quantity. Oh, I should mention, this is by chain rule. By chain rule. So solve for that, divide by this piece, so you get f inverse prime is 1 over f prime of f inverse of x. So right here we have a formula. Lousy prime. We have a formula that gives us the derivative of the inverse. So let's see how we can use that for the derivative of sine of x. Well, in that chart, I did give you the derivative chart from, I guess it's technically 2 weeks ago. This is week 8. So it was our week 6 extension of the derivative rules. On the last page, we have the derivatives of all 6 inverse trig functions. We didn't prove any of them. Let's prove for sine of x. So example, we show, what do we show? That the derivative of sine inverse of x is, what is it, 1 over root 1 minus x squared. So we're going to prove that result using that formula there. So we want sine inverse, the derivative of that. So let's let f of x be sine of x. Let f of x equal sine of x. Well, now we just need to substitute down here. So f inverse, well, maybe I'll write it like this. Maybe this will be more clear. So sine inverse I'll write it like this. There are too many exponents here. So f inverse prime of x is given by 1 over f prime of f inverse. What's f prime of x? Well, f prime, derivative of sine, is cosine. So 1 over cosine of f inverse. So cosine of sine inverse of x. So if f is sine, derivative of sine inverse, which I left as f over there, is 1 over f prime of f inverse, 1 over cosine of sine inverse of x. Well, this doesn't look like that. This doesn't look like that at all. But I will tell you, it does equal that. Why? Side work. I'll put side work up here. Sine inverse x, remember, sine of x tells us what? Sine of x, the input is interpreted as an angle in a triangle. And the output is given by a ratio of sides. So flipping that around, sine inverse of x, the input is a ratio of sides, the output is an angle. So sine inverse x we can see as an angle. Let's make theta equal sine inverse of x. How can we make theta sine inverse of x? Well, we need sine of theta to equal x. Sine is opposite over hypotenuse. So right now, sine of theta equals x. So we'll say, since, I need the other side, so I'm going to leave a gap here to fill in the other side. Since sine of theta equals x over 1, which equals x, comma, sine inverse of x equals theta. In that triangle, theta is sine inverse of x. So what does this equal? Well, it equals 1 over cosine of theta. What's cosine of theta? Cosine is this side over 1. What's this side? Pythagorean theorem. Root 1 minus x squared. So it equals 1 over root 1 minus x squared over 1, which reduces to just 1 over root 1 minus x squared. Now, this is kind of a proof. So I'll say Q, E, D. So in this, we did have to be a little clever in finding the triangle. We wanted sine inverse of x to be this angle. And because of that, we got x and 1. The other 6 trig functions do follow similarly. So this inverse formula could be used for general functions, and the book has one for like x plus 2 over x, but you know, I'm more concerned with the trig functions than ones we could take the derivatives of normally. So there is another example in the book if you'd like to look at it, but you know, I would stick more with trig functions if I asked you anything on these.